Alright, exercise set 1.3.3. This is grade 11. Question 1. A sports car is advertised to be able to stop from a speed of 100 kilometers an hour within 45 meters. What is its acceleration in meters per second squared? How many G's is this? Okay, so things to note. Your acceleration, you should be thinking acceleration is going to be negative because he's going from a speed of 100 to a stop. So he's decelerating or slowing down. So that's a negative acceleration. And how many G's is this? Now we've been talking about the gravitational pull of the Earth, where G equals 9.81 meters per second squared. So what we do in real life scenarios is we look at the forces on the human body based on how much gravitational force there is on the body. So our body's used to 1 G, which is 9.81 meters per second squared. That's 1 G. When we accelerate or deaccelerate our body, those forces are made greater. Like a fighter aircraft, and the pilot might face 7, 8, 9 Gs when he goes into a straight up vertical shot. And that has a lot of effect on our body and the blood flowing through our body, and people pass out and everything else. So this is what we're talking about when we say how many G's is this. So when the car is going to come to a stop, your body's being thrown forward by a force stronger than the pull of gravity. But the question is, how many times greater than gravity? Or if it's slightly less, it might be less than 1 G, less than the pull of gravity. So it's just a comparative thing. Okay, let's get started on the normal old stuff. It's the same old routine. We're going to look at what information we're given. Let me get back to my standard start color. So, from a speed of 100 kilometers an hour, to me that's a VI. And 45 meters, that's our displacement. And we want to know acceleration and how many G's. Okay, so this is all we have. Let's jot it down. I got VI equals 100. Nice. Kilometers per hour. And we need to convert that. And that's 27.88 meters per second. Okay, we have a displacement of 45 meters. We want to know A. Oh, and we know VF. Should have put that up earlier. We know he comes to a stop. Okay. So we want to solve for A, and we have VF, VI, and D. That's the velocity squared displacement formula. Let's just change the color here to make them stand out. So we've got the displacement equation that has VF squared minus VI squared. Oops. All over 2A. Okay. Now I just plug in the numbers. So we know D, it's 45 meters. So 45. So already we know we're going to have to do some algebra to solve for the acceleration. VF squared, which is just 0 squared, nice, minus 27.8 squared, all over 2A. Alright, well, algebra time. Let's get rid of that 2A off the bottom. So we want to multiply this entire thing by 2A. Causes these ones to cancel on the top, and have it show up on the left side of the equal sign. 2 times 45 is 90. And A just stays there with it. Equals 0 squared is 0, so we have a negative 27.8 squared. So even though we're squaring it, it's going to be negative. And now to solve for A, we got to divide both sides by 90. These cancel and give me 1A, which is what I want to solve for. 1A is equal to Okay, so and A is negative. My color's messed. 27.8 squared over 90, which is in the end .6, so negative 8.6 meters per second squared. Now if we want to figure out how many G's that is, we have to take and move everything here at once and solve for G. So a number of G's is just equal to whatever acceleration you're experiencing divided by G. So the G's in this case is 8.6. The direction doesn't matter, so 8.6 divided by 9.81. Okay, so it's going to be less than 1. So it's less than the pull of gravity downwards on us. It actually equals 0.88. And it's just a ratio, so that's it. You're experiencing 0.88 of a G. Finished. Or your written answer. Therefore, the people in the vehicle are experiencing a negative acceleration of 8.6 meters per second squared, which applies a force of 0.88 Gs on their body. Finished.